Okay, let's dive into this. You've brought us some really fascinating source material for a deep dive today.
Absolutely. Yeah, we're taking a close look at what really makes for a successful job interview in, well, a very specific and pretty competitive field, industrial engineering.
Right. And the core of what we're digging into is this guide you shared, outlining some top interview questions for this exact role.
That's the one. Our mission here really is to unpack this guide. We want to pull out the most important insights, helping you understand not just what employers are asking, but, why they're asking it.
And how candidates can show their skills.
Exactly, and crucially, how candidates can really showcase the skills and the mindset needed. It's all about bridging that expectation gap.
Precisely. This isn't just about, like, memorizing answers. It's understanding the capabilities underneath the whole approach. So yeah, let's get into this guide. Let's see what it tells us about navigating the interview landscape for IEs and find that perfect fit.
And I think what's really key right from the start, based on the source anyway, is that the interview isn't just about showing off technical knowledge.
Okay?
It's equally focused on revealing those critical problem-solving skills, adaptability, that innovative thinking mindset, and it's all geared towards one core goal: optimizing systems.
Right, optimization.
Yeah.
Okay, so let's unpack this guide then, question by question, and see what nuggets of wisdom are in there. The very first question listed, it kind of gets right to the heart of it. Can you explain what an industrial engineer does? What's the source highlighting there? What's the core responsibility?
Well, the source gives a pretty concise definition. Industrial engineers are responsible for designing, implementing, and improving systems and processes.
Designing, implementing, improving. Yeah.
And to make sure to point out, this isn't just manufacturing, it extends to areas like construction, logistics, healthcare, really anywhere you find complex processes.
So broad application.
Definitely. The core activity involves analyzing data and identifying areas where things can, well, be made better.
So analysis is central. And what's the ultimate goal they're aiming for with that improvement?
The outcome, the source really emphasizes this, is increased efficiency, reduced costs, and improved safety. That's the core value proposition, really, that an industrial engineer brings: tangible, positive change.
Makes sense. Okay, moving on, the guide includes a question about experience.
Yeah.
What experience do you have as an industrial engineer? Now, this seems straightforward, but what kind of breadth or maybe type of experience does the source suggest is, particularly relevant or impressive?
Yeah, it's a good question. The suggested answer in the source, it points towards experience across various operational settings: manufacturing, logistics, construction, like we mentioned.
Right.
But beyond just the setting, it lists specific skill sets:
Yeah.
project management, process improvement methods, cost analysis, and experience with equipment design and implementation.
Ah, okay.
So it's not just the number of years, it's showing you're proficient in these core areas and, crucially, that you can apply them in different contexts.
Gotcha. This next one is a classic interview staple, just applied to IE. Can you give an example of a project you have worked on as an industrial engineer? The source provides a specific illustration here. What makes this example stand out, according to the guide?
Yes, the example is powerful mainly because it details a concrete project with clear, quantifiable results.
Quantifiable results. Right?
Yeah. The source uses the example of improving a production line in a manufacturing facility.
Okay. And how did they approach it in this example? What was the process they described?
Well, the example walks through using techniques like time and motion studies, a foundational IE tool for observing and analyzing tasks, to really break down the current process.
Right.
This let them identify specific bottlenecks, inefficiencies, and based on that analysis, they proposed tangible changes, things like the layout of the facility, the equipment being used.
So it shows that mix.
Exactly, that crucial blend of systematic analysis and practical, implementable solutions.
Okay, and here's where it gets really interesting, showing the impact.
Hmm.
What were the results reported in that example?
This is where the example truly shines, I think. The implementation led to a reported uh, 25% increase in production output.
Wow, 25%.
Yeah, and a 10% reduction in labor costs. So this really highlights the direct, measurable impact industrial engineering work can have.
Absolutely.
And what's fascinating here, and maybe raises an important question for candidates, is how effectively you can translate that complex analytical work into these kinds of clear, business-relevant outcomes during an interview.
Good point.
It's not enough to just say, you did something, you got to show the impact.
It really drives home the value proposition. Okay, so beyond projects, the next question looks at the specific toolkit. What tools and techniques do you use as an industrial engineer? What specific methods and maybe software does the source highlight as essential?
The source lists several key techniques: time and motion studies, which we just touched on, statistical process control, that's about using data to monitor and manage quality and consistency, process mapping for visualizing workflows, and of course, cost analysis.
And what about specific software tools? Are those mentioned?
Yes, it notes tools like AutoCAD and AutoCAD Plant 3D, which are used for designing and modeling facility layouts, complex systems,
Hmm.
and various simulation software.
Mm.
That lets engineers test changes virtually before they, implement them in the real world.
Right, test it out first.
Exactly. This list really shows the reliance on both those established analytical methods and the modern digital tools for design and analysis.
Makes sense.
Yeah.
Now, in any dynamic field, staying current is crucial. The guide asks, how do you stay current with the latest industry trends and developments? What avenues does the source suggest for that continuous learning piece?
Well, the guide emphasizes a commitment to ongoing learning through several key methods, things like regularly reading industry publications, journals.
Standard stuff?
Yeah, pretty standard, but important. Actively attending conferences and workshops, both for learning about new tech and for networking, and participating in professional organizations relevant to IE.
And it's not just about passively consuming information, is it?
Exactly. The source also points to the importance of networking with peers and mentors, that informal learning, sharing insights and challenges with others in the field. That's often crucial for staying ahead of new technologies, new best practices.
Yeah, that tracks.
What's interesting here is how the source stresses this blend of formal education reinforcement and that practical, peer-driven knowledge exchange.
Okay, the final question on this list tackles a core competency. How do you approach problem solving as an industrial engineer? How does the source break down the recommended method for tackling issues?
The source outlines a really structured multi-step approach, which is, well, very characteristic of industrial engineering thinking.
Okay, step by step.
Yeah. First, it starts with gathering and thoroughly analyzing data to fully understand the problem. No guessing.
Data first.
Always. Second, using tools like process mapping or root cause analysis, they drill down to identify the underlying causes, not just the symptoms you see on the surface.
Get to the root.
Exactly. Third is generating and evaluating potential solutions based on that understanding. Fourth step, implementing the most effective solution.
Makes sense.
And finally, step 5, and this is critical, monitoring the results to ensure the problem is truly resolved and the solution is actually sustainable.
Right. Did it stick?
Precisely. This structured, data-driven, and sort of iterative method ensures effectiveness and gives a clear framework for tackling complex issues.
So it's a systematic process, diagnosis through verification, always grounded in data. Okay, so what does this all mean when we connect it to the bigger picture for you, the listener?
Well, if we kind of connect the dots across these questions, understanding what the source highlights gives you deep insight, not just into how to answer interview questions, maybe, but into the fundamental mindset, the core skills, and the value proposition of an industrial engineer.
Right.
It's about being that analytical, data-driven problem solver focused on delivering measurable improvements to systems. That's the essence.
Yeah, so whether you're maybe considering this career path, or perhaps you work alongside industrial engineers, or you're simply curious about how complex systems get optimized. These points really highlight that essential blend of analytical thinking, practical application, and a relentless focus on efficiency, cost reduction, and safety that the field values.
And the source also lists related job titles, things like continuous improvement engineer, efficiency analyst, factory layout engineer.
Oh, interesting.
Yeah, these show how these core IE skills, process analysis, optimization, layout design, data analysis, they branch out into various specialized roles, but they're all centered around making things work better. Which, raises an important question. How broadly applicable is this focus on efficiency, process improvement, and data-driven results, even beyond those traditionally industrial settings?
That's a really great point. Food for thought. So we've seen how this guide defines industrial engineers by their ability to analyze, improve systems, backed by specific tools, that structured problem-solving method, and always driving for concrete, measurable results.
And that emphasis in the source on demonstrating specific quantifiable impacts, like that 25% increase in output and 10% cost reduction we talked about from the project example, that's a really significant takeaway, I think.
It really makes you consider, doesn't it? How often do we consciously track and quantify the impact of the improvements we make, whether that's, in our professional projects or maybe even just trying to optimize processes in our own daily lives? Definitely something to think about.